we're going to be talking about adding and subtracting polynomials. David, where's your pencil? Go get it.
Please just don't take too long for it to start.
Okay, Kareem, focus. Go ahead. So we're going to be starting adding and subtracting polynomials. So similar to what we did before, we're still going to be collecting like terms, so it's nothing new. The only thing different here is that we're going to have multiple pairs of like terms. Okay, so we're going to have maybe 3 sets of like terms, 4 sets of like terms, and we have to add and subtract them together. So there are rules to adding and subtracting polynomials. So the first one is to remove the brackets and collect the like terms. So what this first rule means is that I'm going to have my questions written as this. So let's say I have 2x squared plus x minus 3x minus 2. So when I have a negative outside of my bracket and I want to remove my bracket, what do you think is going to happen to all the signs on the inside of that current bracket? Are they going to stay the same or are they going to change? Kareem, they're going to change. So my positive 3x becomes what? And my negative 2 becomes? Which is positive 2. So this becomes 2x squared plus x minus 3x plus 2. So minus 3x. So what are my like terms here? Remember, like terms are where the variable part is the same. So what are my like terms in this question? Matthew?
2x2 and 3x?
Nope. X squared and x are 2 different terms. Which one? Thank you, Keegan. X and negative 3x. So x and negative 3x. So I can write 2x squared. What's positive x minus 3x? So remember, we leave the variable part alone. Okay? So now what we're looking at is the number in front of each variable. So what's the number in front of the x? Adam? 1. So we're going to do 1 minus 3, which gives us? Yep. It's going to be minus 2x plus 2. Let's do a different one. So let's have 3x plus 5 minus 8 minus 2x. So I want you guys to try that one on your own, the one in red. So remember, if there's a negative outside of the bracket, when you remove the brackets, everything on the inside changes its sign. Kareem.
I get this one. Is it 3x plus 5? 3x plus negative 3.
No. So when you remove the bracket, what comes after plus 5?
Sorry, wait. Are we doing it in sets?
Yep.
3x plus 5, and then negative 8.
Yep.
And then positive 2x.
There we go. Okay. So what are my pairs of like terms? I have 2 sets here. What's the first one? Claire? 3x and 2x. What's my second pair of like terms? John?
5, 8.
Remember, negative 8 minus 8. So you can either do it all like this. You can write the next line down, but it's not mandatory. What I sometimes like to do is group the like terms together. So I'll have 3x plus 2x plus 5 minus 8. Like I said, this line is not mandatory, but if you feel like you're more organized this way, feel free to do that. Yes, Kareem?
Is that the final answer?
No.
Okay, I'm about to see.
What's the final answer?
5, positive 5x.
Mm-hmm.
And then negative 3.
Yep, 5x minus 3.
There you go, dude.
5x minus 3. Pretty easy, right?
Is there market?
I don't know. You tell me.
Remove the brackets.
There's always.
It's always going to be harder.
Math, what do you think?
Okay. Now, instead of a negative, there might be a positive outside of the bracket. So if there's a positive outside of the bracket and I want to get rid of the bracket, does anything happen to my signs or do they stay the same? Anyone? Remember, we said if there's a negative outside of the bracket, my signs change. But if there's a positive outside the bracket, what happens to my signs? Alice? They stay the same. So when I remove that bracket, it becomes 3x3 plus 2x plus 4 minus 2x cubed. So now you have to look for like terms. Are there any sets of like terms here? Kareem?
3x to the power of 3
Okay, is that it?
yeah.
Perfect. So again, I'll write the next step because I like writing it. You don't have to. So what would my final answer be? Kareem?
1x to the power of 3 plus 2x
Yep.
plus 4.
Perfect. Kareem, you're on fire today.
Oh,
That's our signature.
So yeah. So the reason why I did like terms first is so that this becomes easier for all of you to do. So we have one more lesson left in this unit. I just stumbled upon that today. So you guys know what that means.
Oh no.
No.
You enter the T.
On Friday.
Oh,
On Friday?
Yeah.
Next Monday.
It's the only Friday test I'll ever had was this one.
No.
Yep.
No.
One more unit. Then we have like 2 more months.
Yeah, we have like 4 more units. 5 actually.
One more lesson for this.
Yeah, one more lesson.
How many lessons? How many units are there?
Like 8?
Huh?
Yeah, we have 6 more. We have 6 more.
Hey.
So do you guys find this stuff pretty easy now?
No.
For now, we'll do more examples. I'm not gonna. Okay. So again, remove brackets and collect like terms. If there's a negative outside of the bracket, everything on the inside changes. So another, I guess, quick review of like terms. So like terms are terms in polynomial expressions or equations that are the same. They share the same characteristics, okay? So 3x and 6x, they are like terms because what? Austin, they have x. The variable is the same.
Wait, so this is simplifying and not evaluating. Right?
We're still simplifying. We're not evaluating.
So if you're simplifying, you would like do the whole thing and
Mm-hmm.
add it.
Mm-hmm. Okay. 3x squared and 4x are not the same. They are not like terms. Why are 3x squared and 4x not like terms? What makes them different, Matthew?
3x is squared.
Yep. So x squared
And x is different.
and x are different.
1x is m squared.
Mm-hmm.
X squared and X are different.
Unless like the other x was x cubed.
Yep. X cubed. Yes, Sean?
With like 4x squared and 3x cubed, are those like terms or?
No, because x cubed is different from x squared. The exponents have to be the same for them to be like terms.
He says something that's different, it would be different.
Mm-hmm. Now, your exponent laws knowledge. Are 5x squared and 2x to the 4 to the power of 2, are they the same? Are they like terms?
5x squared and what was it?
And 2x to the power of 4, all to the power of 1/2. Alice, why?
Because 2 times.
Mm-hmm. So this is called what? What kind of rule are we using here? Something of a something. Sean.
Multiplication.
Yeah, but what's that? What's the exponent rule called? Austin?
Isn't it like a power to a power?
The power to a power. Power of a power rule, which means, like Sean said, we're going to multiply. So I'm going to take 2 to the 1/2 because that half goes to the 2 as well. And x times 4 times 1 over 2. So 4 times 1/2 is what? 4 times a half. What does that give me? Gian. 2. And as you can see here, I have x to the power of 2, which means that they are like terms. Okay? So there are going to be times where I can throw that type of question to you, and you guys are going to have to identify that. On the topic of like terms, just to see if you guys understand, I want examples of like terms. Also, this lesson is very short, so we might be finished early. Matthew, give me one.
3x and 2x.
Mr. Garcia, do you want us to memorize like the definition of that, or-
No, I don't like making you guys write definitions. What are other sets of like terms? I'm gonna give you another example. Kareem.
5x to the power of 10 and 2x to the power of 3.
Would you say 5x to the power of what?
5x to the power of 10, 2x to the power of 3.
Nope.
But I thought you explained. Oh,
My other one has to be 2x to the power of 10. Okay.
All of them have to be.
Yep. Sean,
-4 and 10.
-4 and 10. And someone else give me one more. Adam.
2x cubed and 6x cubed.
Perfect. So as you can see here, each like term, the variable part is the same. This one has no variable, which is fine. This. So this is a term. So 3x squared. Which is my variable? Which is my coefficient? See if you guys remember. Gian. Yep. So my 3 is my coefficient because that number never changes. And x squared is my variable because I can assign any value to x. Everyone good so far?
Yeah.
We're cruising. Remember, if you're not doing as well as you think you are, it's always better to change your habits early than later. All right. So now we're going to get into some examples in a couple of seconds. I'll give you guys a minute to just finish copying this down. We'll do some examples, and then you'll have the rest of the period to work on practice. Tomorrow we will do the last lesson, and then Wednesday, Thursday will both be review periods. So that way I'll make a Kahoot for like a review, and then I'll give you guys a review worksheet. You guys can work together on that, and teamwork. Yeah. So just finish copying this down if you have not.
That's so short. I want like 3 parts.
I like my lesson short and sweet. Okay.
Mr. Garcia?
Yeah.
You guys are watching?
I'm copying the lesson, but I figured something cool I want to show you.
Okay, show me after.
It's actually cool.
All right, so the first example we're going to look at is 2x plus 4 plus 2x minus negative 2. So we want to simplify this first, so we're going to do it by going through some steps. So I want to identify the like terms and underline them using different colors if you would like. However, there is a bracket there. What is negative minus negative 2? What does that become, Austin? Plus 2. So this is going to be 2x plus 4 plus 2x plus 2. So now I'm going to highlight or underline using different colors. You guys can do that if you want. Or you can use like boxes and circles. Doesn't really matter to me. So what's my first pair of like terms? Matthew.
2x and 2x.
Yep, 2x and 2x. What's my second pair of like terms? Matthew.
4 and 2.
Positive 4 and positive 2. So like I said, you don't have to do this next step, but if you want to, it's highly encouraged. 2x plus 2x plus 4 plus 2. So what does my answer become? Kareem. There we go. It's easy as pie.
10x?
Nope, because 6 doesn't have an x, so you can't say 10x.
How much if you added a plus x to the third, and then it'd be
5x.
no, like 6 and x.
Oh, so it'd be 10x. Yeah, Sean.
10.
When you rewrote the equation,
Mhm.
do you have to change the two negatives beside each other, or can you just do that after?
Do it first. It's easier to get it over with.
Wait,
Yeah,
oh,
that's unfortunate.
this is
Okay.
uh,
Okay, we'll get back to you. Let me do the next example.
is this not
Okay, now let's try these examples. So I have 5a, which is 5x squared, plus 2 minus 3x, plus 4x minus 2x squared. Yes, Kareem.
Sorry, is this how you like simplify like all the equations, like generally all of them?
So remember I told you guys when we're writing polynomial expressions, do I want highest exponent to lowest or lowest to highest? Highest to lowest. So what are my first two like terms? Hey, Yazin? Yep. So I get 5x squared and minus 2x squared. Next pair of like terms. Kareem.
Negative 3x and 4x.
Okay, and then 2 is by itself because it's a loner. So I get 5x squared. Like I said, you don't have to do this line, but I just like doing it for the sake of people who find this more organized. Okay, so let's start with our first two. 5x squared minus 2x squared. What does that give us? Austin.
3x squared.
Okay. What's negative 3x plus 4x? Matthew.
1x?
Yeah. So plus x. We don't have to write the 1 because if there's a variable with no coefficient, it's automatically 1.
I guess go 1.
And then plus 2 is by itself.
And you can add them as an x?
Nope.
You can add 2 as an x.
So our simplified expression is 3x squared plus x plus 2. We'll do B together and then C you guys will, actually no, we'll do B and C together and D you guys will do on your own. So I got B is negative. Plus 3 minus negative 2 plus 3x minus 2x squared. So what's the first order of business here?
Not doing.
What's the first order of business here? We have brackets. What do I have to do with them?
Remove them. Destroy.
Okay, Sean, how do I remove the brackets?
Well, for 4x, we're just the plus.
Mhm. So positive 4x plus 3
And you change the -2 to a positive.
plus 2 plus 3x minus 2x squared. So now what are my like terms? Austin.
4x.
Okay. And Sienna, what's my other pair of like terms? Perfect. 3 and 2. So let's rewrite this. So we're going to start with my negative 2x squared plus 4x plus 3x plus 3 plus 2. So what does my simplified expression become? Austin.
Negative 2x
Yep.
squared
Mhm.
plus 7x
Yep.
plus 5.
There we go. Good job. So we got negative 2x squared plus 7x plus 5. So take a moment to copy this down. So now my next one is 3x plus 4 minus negative 3x. So what's the first thing we are going to do? Austin,
Bracket.
bracket. So what does it become?
Plus positive
Mhm.
3x.
Plus 3x. So now what's my only pair of like terms? Yazin.
2x and dx.
Perfect. So I got 3x plus 3x plus 4. So what's my final expression? Austin.
6x plus
6x plus 4. Perfect. So now I want you guys to try D on your own.
After you get 6x plus 4, wouldn't you have to do that?
No, because there's no x with the 4, right? So you just leave it as 6x plus 4. So do D on your own. See if you guys can try and solve that. Take a couple minutes to do D. So, last example, we have so is guys is AB and BA are those like terms?
Yes.
Why?
Because
Because what?
They have the same variable.
Okay, Maya. So BA, AB, same thing. It's like 3 times 5, 5 times 3 gives you the same answer.
But like when you get your answer, would it be what you write your
You can write BA or AB, doesn't matter. So the first thing I need to do is get rid of that bracket. So remember that bracket, if there's a negative outside, you change the signs on the inside. So what are my sets of like terms then? Maya. Okay, and what's my last one? Someone else? Claire? Yep. And then minus 2 is by itself. So I have 3AB plus 4BA plus 2Y plus 4Y minus 2. So what's my final answer? Caitlin.
7AB
Mhm.
plus 6Y minus 2.
Perfect. Good. Yeah,
I wrote it as 7AB minus 2 plus 6Y.
that's fine. I usually, if you haven't noticed, the constant's always at the last. So is everyone good with this concept? So what I'm actually gonna do is I'm gonna put up an exit ticket. Wow, we usually never do those, but
What's the next?
basically you answer a question and I check it to make sure you understand the lesson.
So you can't leave if you can't do it?
Yep.
Hey, Yasin, we got that once in geography.
It's a hostage. You guys are staying past 2:30 if you guys don't get it.
You're saying if I get it right and David doesn't, I can go to the door and dance on him because he didn't get it right.
No. That's rude.
He didn't get it right though.
So you guys can either take a picture or type it in on the thing. So this is your exit ticket question. I'm going to pull it up on the board. So it's over here. This is it. So do not put your answer on this document. Okay? Do not put it on the document. Write it on your paper, take a picture, or type it in as a private comment. So that is your exit ticket. So you guys are going to be doing this first. And then you guys are going to be doing the attachment, this work over here, adding and subtracting polynomials, this worksheet. This is the exit ticket.
Where do we write it in private comment? Where do we put it in private comment?
You can type it out.
Like, and just